This is Storage Field Day 16. I'm Vince Westin, Technical Evangelist for PowerMax. We're glad to have you here. All right, so let's talk about machine learning and whatever we want to call AI as part of the context of all this in terms of storage. So we see a lot of things at the server level where people are doing machine learning and artificial intelligence applications. They can use lots of latency. They can use lots of bandwidth. Right? Low latency, high bandwidth is exactly what they're looking for. We want to be able to provide that. We think PowerMax is a great source for that kind of data. So that's all we're really going to say about the servers on this. Our focus here is going to be on the array side. But on the array side, we've got analytics and optimization that we want to do in the little brain here inside PowerMax to make our system smart, to make it work better. Again, our goal is to work smart, not hard. So we want to get the most we can out of our hardware. And then we also have Cloud IQ for extended analytics, where we have the ability to pass information up to the cloud and let our cloud repository look at things. And you have Susan Sharp coming in after me to talk in depth about Cloud IQ. So I'll just make a few references to it, but I'll let Susan really explain all the details of what we're doing with Cloud IQ. So how are we doing this? What are we doing it? Why are we doing it? So what are we doing? We're implementing some machine learning within PowerMax to serve our I/O requests with the lowest possible latency. All right, pretty simple. It's all about latency. How do we drive that down? What are we doing to do that? We're looking at fine-grained workload profiles to understand the nature of the workloads that are being run on the system, to be able to optimize for the likely future workload that we're going to see. All right, it's all about predicting the future. It's easy to predict the past. It's very difficult to predict the future. Right? I'm pretty good at predicting the past. And then why are we doing this? Again, all optimizing around the configurations. How do we help you get the most value out of the hardware you're buying? So what are we doing? We're looking at workload characteristics. We're looking read, write, copy, whatever's going on, block size 8, 12, 64, whatever. Where are you on the LUN or the logical volume? Where are you on the block address within that? Locality of reference spatially in the LUN, across LUNs, what tends to be happening together, and looking at patterns across days and across regions of the I/O profiles to see what's going on in the within the system, right? So we have both locality of reference in terms of addresses and temporal locations in terms of time, right? How frequent is it? And so if you look at the heat map version, right, this kind of says, gee, there's a whole bunch of this data that's not doing much. These things have little peaks, and this has some really big peaks. And if you look at this, there's a certain pattern here. What do you guess the really hot parts on this might be?
Nightly backups?
Yeah, right. It happens 2 days out of every 7. Backups on the weekends. Yeah. Amazing to think that so many of our systems still get slammed more by backups than anything we do in production. But that's the way a lot of things run in the real world. All right, so what's the opportunity here? We want to look for workload characteristics, right? What's the type of the workload? What's the size? How are the locations based? What's the frequency of the repeat? And then we want to do optimization for that. What do we reduce? What do we not reduce? What benefit from being on the storage class memory? That's an SMC, not SCM. Threw me for a loop. What would benefit from being on storage class memory? What would benefit from being on NAND? What would benefit from being tiered out to the cloud at some point if I've really ignored it for months? We're looking at some of those kinds of things. We're actually building some things to tier to the cloud. The only challenge is, how many of you remember when we rolled out the SATA drives for tiering within VMAX? Right, we did that many, many moons ago. The challenge with that is when you tier things to it, it does a great job of freeing up space in the hot tier. The problem is if you're ever going to use it, right? Because the response times are awful, but at least the bandwidth is low. Right? I mean, it's really bad all the way around. So we've got to figure out how to make sure we don't do that with anything that's anywhere near active. So optimization of this stuff is critical. So what are we doing? We're capturing stats across the controllers, across the volumes, across the system. We're storing lots of data. For a 200 terabyte typical capacity, it's 40 million samples per array per day. And we have to manage and groom the statistics and the history, and how do you figure that out over 30 days, and how do you map it all and not keep every bit of all the data you've got on the performance, and how do we analyze all that? So what we want to do with that is we want to build an infrastructure that helps us use it. So we start with service levels for the old mixed drives, and then we said, okay, we can optimize based on space efficiency for VMAX all flash. And now we're saying, well, we're going to add service levels so we can start slowing things down on bronze and silver, and how do we manage things best to the service levels? And then how do we really apply that as we mix in the storage class memory and such? And so it gets kind of complicated, right? You collect all this data from all the LUNs, and what am I doing for I/O, and what's it hitting like? And then I go back and do multiple variations of what do the patterns look like, right? And try and really describe the features of what I'm seeing at a more advanced level to understand the types of workloads I've got, feed that into my forecasting engine, which then decides how to rank the different pieces and where I'm going to store them, pass some of that off to Cloud IQ, so Cloud IQ knows what's going on and what we're doing and where our priorities are and what we're seeing for patterns. And then run that down and go activate it and make it work, and then push some of the results back into the forecast and take the results from here and mix it and rinse and repeat, right?
So this is all on array.
This is all on array, right? Got a little brain sitting here on the array, chunk, 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 chunk.
So we're looking at NVIDIA GPUs to do your ML next generation?
No, we've figured out how to do this without needing a whole lot of extra stuff.
Okay.
Right, we're not trying to do full-blown AI, go figure out how to solve the world. This is more of an expert system kind of thing, right? Expert systems goal is to say, I look at A, B, and C, I match it with the pattern, I go do E. Right? And so you don't need the same kind of computation. If you're really doing artificial intelligence and learn new things,
yes,
right, that needs more intense stuff. We're not doing that. That's why we're specifically trying to call this machine learning.
Yeah.
We feel that's fair for what we're doing. We could try and call it AI. We think that would be a stretch of what we're doing.
Well, it's a known problem domain.
Yeah.
You know all of your inputs. You know
right.
exactly
We know
what
the
they're-
inputs. We know the out. We don't know what the real workloads are.
Right.
But we know how they look.
Yeah.
Right, and we know enough about it that it fits into a fairly defined class. Now, there are things that are outliers that we aren't going to get. And if we added real AI, could we figure some of those out? Probably, right? Because we're not looking at trends that go over 24 months or 12 months. So we don't really know what it's like when you have annual cycles that come around and do your end of year budget cycle. We don't see that, right? We're keeping things 30 days or so, and that's it. So quarter end, year end, annual cycles don't really mean anything to us. But we don't think we'd get that much value out of it right now. So we're trying to work on the small stuff first. And then you can add other intelligence outside. Now, the other option is, right, since Cloud IQ is already in the cloud and has access to more stuff, you could say, gee, I've got some arrays that are really busy. Now I could take Cloud IQ and have it go look at some of the data more intensely and say, I think you have this other kind of pattern laying on top of this, and it could start at some point feeding data back in. Right, of, by the way, plan for or think about this possible addition to your feature description. Right? But we believe that that's going to be better served up here in Cloud IQ.
Makes sense.
Right, because it's got more processing power, it's more dispersed, and it can also see more workloads. Because we'll talk when you have Susan come in. She'll talk some about how it can also recognize, because it's Cloud IQ and sees lots of things, not only the arrays in your data center and across your data centers, but across all of our installed environment. Right, so we can look for patterns and say, hey, there's something really interesting going on everywhere, right? Or on this 30 set of frames or whatever that may belong to different customers. We can go figure things out.
Hey, Vince, real quick, on the forecasting, if you're only going back, you said, what, 30 days?
Yeah.
How can you actually properly forecast if you're not seeing the past performance for longer? If, say, I'm a tax shop and I just happen to install the new system in June, right. You're not going to get my performance or the impact on my business that it would be annually around.
We're not going to know what you're going to do in April until April. Yeah. Absolutely. And you know what? When you come around the next April, we still won't know what you're going to do in April because we forgot about it 11 months ago. Absolutely.
As a problem.
Well, so the trick is that the time to run through this cycle is measured in minutes to hours, not days. Right? It's an all-flash system. So on the bad case, if we've done it wrong, you're compressed on NVMe all-flash. Right? It's not a far drop. It's not like you're sitting on 8 terabyte data tubs in the corner and suddenly I'm trying to do 10,000 reads from a drive that does 100 a second. Right? It's not the same class of problem. So yeah, it's not perfect. But again, it's not trying to be perfect. It's trying to be reasonably intelligent for most things.
So you're using this to determine what tier of storage to put a particular LUN on or something like that?
Yeah. So right now we're deciding between compressed and uncompressed, right? And the next thing will be,
SCM,
if I'm uncompressed,
yeah.
do I go on SCM or do I just sit in uncompressed on NAND, right?
So you're not making real-time cache hit decisions based on this. You're more or less talking about tiering of data.
Right. Where do you get stored on the back end?
In the old days, you would have had some sort of an array of hot data versus cold data, somehow distinguishing almost on a track-by-track basis or whatever your granularity was. You're not doing that anymore?
This is all track level granularity. Yeah.
In the old days, before machine learning and AI, you would have had some sort of table that you would try to maintain hotness versus coldness on a track-by-track basis.
Right.
You're not doing that anymore because you're using this?
Well, we're doing that. We're doing both. Right. So this guy is helping you decide. So you have the combination of how hot am I, right? How hot was I 4 hours ago? How hot was I 2 weeks ago or 4 weeks ago, right? What are my long-term and short-term averages? And which feature am I a part of, right? Because I may not be that hot today or yesterday, but I've seen lots of bursts in this workload, so I may decide that that's worth tiering up anyway. So again, the goal here in the ranking is more than just the temperature of the data. It's the actual overall feature depiction. And sometimes you promote things just because the tracks around them have been somewhat hot in the recent past. And so I'd rather keep them together because it'll get me more. Scott.
Yeah, and so just keep in mind that this doesn't necessarily only apply to the back end
of the system where the drives are. We're also managing the front-end queues, so as I/O is coming into the box, if we see that there is a particular workload that's missing its service level score, right? It's supposed to be sub-millisecond and it's tripped over a millisecond. What we're going to do is we're going to say, okay, so you're missing where your performance target is supposed to be. So what I'm going to do is I'm going to shift around the queues off of the front end so I can get more of your I/O serviced faster so I can get you back into compliance with the performance service level. So that's just one example. Again, it's not completely isolated to the back end. There's lots of things that are happening within the front end, the cache, the back end, et cetera.
We also talked about service levels, right? So if you have a bronze service level, the odds of you not being compressed and deduped at every stage is almost zero, right? Because you don't have any priority. So we'd rather push you to the back end and minimize you because you're always going to be the slow guy, right? We don't care. You never get any priority in here at all. Whereas if you're diamond, even if you're the same speed as somebody who's gold in terms of I/O repetitiveness, right? If you're the same frequency of attack, you will wind up getting a higher priority, a higher ranking in the system because of your service level. So it's a little more complicated than just look up on a table and go. Not a lot more complicated, but it's making the table is a little more complicated. How about that? And then you rinse and repeat.
Quick question.
Yeah.
This feature here, is this all custom developed by Dell EMC?
Yes.
Or are you, all right.
This is long-term custom development by PowerMax Engineering.
So you're not leaning on a third-party provider for the AI functionality?
All of this, well, again, this isn't dramatic AI.
I understand.
Right. We're looking at trending, and we've got guys who've been doing this for longer than I've been here, and I've been here 23 years.
Yeah, a lot of this is IP that's been patented over the last several years. So this is stuff.
Some of it in the last 5, and some of it in the last 30.
So this is stuff. A lot of this is stuff that's very unique to this implementation and what we're doing.
Yeah. What we do is very different from what almost anything else in the world does. So using some outside code probably wouldn't help us much. And we also need it all very optimized to run in the confines of what we're doing without overloading. Again, you're looking at millions and millions of records every hour.
Yeah.
And not impacting
and feeding Cloud IQ, that's through the call home interface?
Right, so this is going to go through the ESRS gateway.
Yep.
This is currently in beta or early test, we can call it. So
early access.
Early access, they're proper wording. I think that's on the next slide, but yeah, or coming up.
And this is a part of the current support agreements that people have?
Right, so they already have the ESRS gateway.
So
we've been pulling data back into a system we called SYR that allowed our internal guys to go look at things and didn't tell anything to the customer. Right, so we had some interesting information about your system, and the customer could come and ask their sales team, but that didn't really help the customer. And the Unity guys developed Cloud IQ, and they said, hey, we got this great way to go analyze data on the arrays. And the VMAX guy said, ooh, help us, right? We want to join you. And so Dell has kind of spread this out. So now Cloud IQ, against you're gonna get a whole talk about this. You're gonna have 45 minutes or an hour on what are we doing with Cloud IQ and how we're expanding it to cover all the storage platforms, because we've decided that's just a great idea to make it easy for you all to get this kind of access and intelligence across all your platforms.
Yeah, just to be clear, there is no license charge for this. This is included.
Got it.
Okay.
And how does this complement customers who are running SRM?
So the SRM is designed for your local view of where things are being used. This is more of a system level view of health and all. Again, we're going to get into all the Cloud IQ pieces in the next talk.
Yep, got it.
I think that'll kind of make that clear. All right, so this is proven machine learning, right? Active in thousands of systems today. 2 exabytes under management already. 325 billion sublun segments are being forecast in real time. Right? I mean, this is not something that's just getting started. We've been doing this for tiering across drives. This is something we've been working on for years in terms of how we do this. We have new ways of describing it now using the terminology around machine learning and all. It's what we've been doing. We're now properly describing it. So we think this is going to be really useful for helping us optimize storage class memory, because storage class memory, again, has a limited capacity in the near term, and it has a very high expense in the near term. And so we want to extract absolutely every bit of value we can out of the storage class memory devices.
You say a cycle for that is like on the order of minutes?
In general, we're doing a cycle of the analysis in this every 10 minutes. Yes. Right, we're doing real-time data collection, so we may adjust things. If you find something suddenly getting very hot, it may decide to adjust faster than that. But we adjust the templates of what we're doing about every 10 minutes in the frame. Yeah.
Hey, Vince, a different question. I don't know if it falls under the machine learning aspect, but do you have auto provisioning for apps within PowerMax?
Sure. What kind of provisioning? We got access with APIs. We can do.
I
all
need a
kinds
certain I/O throughput for an app. Can I define that automatically and have it provisioned for that application?
Yeah, you can set host I/O limits and how many I/Os do I need and all that
And
stuff.
it doesn't matter which hypervisor you're on?
I mean, you can go build that easily. I don't know if the hypervisors can describe the LUN that way or if they do that, but we've got the whole, for example, we've got the VSI plugins that work with both the ESX, right? I'm assuming most people are on 6 or 6.5, but it goes all the way back to 3.5 or 4. We've been doing integration with VMware forever. We've got kind of a partnership going on there. Don't know how that would happen. But we also do it with Hyper-V, right? We've got work going on around what's going on with Docker and all those things. We've got the ability to use Chef and Puppet, and then we can use, we'll talk about the whole management thing coming up. So let's talk about it there.
Thank you.
Yep. All right, so now we're going to jump into a few minutes on security. So when you look around your house, right, you don't have one way to defend things in your house. You have multiple layers of things. Not everything belongs in the safe. Right? If you locked everything in the safe, you couldn't use it very well. So the very valuable things that you use less often, you keep in the safe. Similarly, we do security in layers in storage. We have to protect everything, so it all gets locked up with DARE in general. But then around that, we start doing things like secure snaps and user management through role-based access controls, remote support, and then FIPS compliance and all those kinds of things for certifications to make sure it's all getting done the way you think it should be. Right? So security builds in layers. We have a whole bunch of pieces about security. You've got certified data erasure. You come to us and you say, hey, I want to pull this frame out of my data center. I can wipe the whole thing, give you the certificate, take the box away. Data at rest encryption, of course, because you've got to have that. Secure snaps, I think we're going to talk about in the next slide. But being able to protect your snaps from being deleted. Role-based access controls, being able to decide who gets access to what and why, so that you can pass down control so that a DBA can make snaps of their database and they can restore it, but they can't restore it on top of somebody else's database, right? Some of those things are kind of important. Being able to use service credentials for our customer service guys, so when somebody walks in your data center, they say, yeah, I'm here, I'm from Dell, I'm going to help, and they go log in, right? They have to use their two-factor authentication to get into the system, and if they've been terminated or if their access isn't right for that system or they haven't said they're going to work on it, they don't have the credential to get past the two-factor authentication, it doesn't work. Right? So lots of security there. Secure remote support on that remote support gateway. Audit logs, we'll take all the logs and stream them, and you can archive the logs and be able to go do all the log surfing you want to make sure you know what's going on with all the security pieces. And then the common criteria certification as well. So simple things, data at rest encryption, right? Every bit flows through encryption hardware, comes out the other end, one key per drive. You pull the drive out of the array, send the drive off, we shred the key. Key and the drive are never together, no problem, data is secure. Install a new drive in the box, we generate a new key for it, right? Key lasts as long as the drive's in the box, done. So fairly simple stuff, all done in hardware. If you want to, you can do remote keys, so you can have an external key manager managing the keys in the array. I far and away prefer to leave the keys in the array because these keys are not actively manageable. Right? If you reach in and change all the keys for your array and you're managing the keys, you just wiped out all your data. That's generally a bad thing. Right? So rather than doing an external key manager, if you just leave it in the box, nobody can muck with it, nobody can change your keys, nobody can get to them, they can't be exported by a user and taken out of the building or something, they're secure and done.
So compression and deduplication and encryption, how is that layered? These are drive level?
So this is done in hardware on the card.
Software encrypted, it's self-encrypting drives, what you're talking about.
No, it's a chip running on the NVMe card that's sending the data down to the drives. So we're doing it in hardware before it leaves the director, but it's done on the way to the drive in hardware. It's like having self-encrypting drives, except we only have one chip for the drives. One chip per controller. There's a slick that pushes the data out to the drives. It encrypts it on the way.
So the link thing, the link chain, the link card, is that where it's done? Or
one step above that, in the director.
In the director itself.
The Blaze Devil slick brings the data in, encrypts it, pushes it down. Or reads it up, unencrypts it, passes it back up.
So it's after compression, after deduplication.
Yep. So this has no impact on any of the data surfaces at the higher levels of the array. It's just a hardware piece as you go to the drives. Now, as we get to, the self-encrypting drive thing is getting more standard for high bandwidth drives. But for example, next year when we do storage class memory, there won't be any STM drives that are self-encrypting next year, right? So we wouldn't be able to do that as quickly if we were waiting for the drives to do it. Going forward, we expect that all the drive vendors are putting that into their low-level specs on their firmware. So we may start using self-encrypting drives over time. But for right now, we're doing it at the controller level. We have trusted multi-tenancy, and we have this idea of being able to isolate data. So you're able to decide who gets access to what. You're able to securely use things with role-based access controls and what we call SIMACLs, the access controls. But the role-based is kind of a higher level, easier to manage version of that with better resolution at the user level and storage group level and such, rather than being for whole arrays. We also have tenant-to-tenant data protection. So if you have a LUN running in a box, right, some of that data may not only tier up between storage, but you may delete LUNs and leave a whole bunch of data sitting around, right? All of those tracks in the box are marked as invalid. So when you start allocating new tracks, they're all zeroed on write. So you can't ever read any of the old data. So everything is protected. There's no leakage of data between LUNs.
So, I mean, with the wide striping and all that stuff, you're actually mixing up any volumes data on any of these drives, right?
Right. Every drive essentially has data from every LUN.
And then as far as the multi-tenant is concerned, a LUN is obviously assigned to a particular tenant, let's say.
Right.
Right.
So the keys don't go with the LUNs, so it's not key-based encryption.
Keys are
The security is based on access to the tracks, not based on data at rest encryption. Because the track is only accessible by the LUN it's a part of. And then when it's invalid, and you can go, somebody else can say, hey, I want to use that track. Great, it's all filled with zeros. Right? There's no reading of the old data. It's all wiped automatic.
Okay.
So that's one of the things, the security guys are rather insistent, and they do testing on that to make sure there's no way to leak data back and forth between LUNs. Kind of like they do with VMware, right? Can I leak data between the VMs? They do the same kind of thing with us between LUNs, just to make sure that there's no way to have data accidentally feed back and forth. Now, obviously, if you take a snap of one and restore it on another, right, that's not an accidental. You caused the data to move between LUNs. That's a whole different discussion of your security and how you're going to manage things. The new role-based access controls, so you have the ability to assign different roles. We've got things like local replication, remote replication. I can manage a device, allocating storage. I'm the wizard of all things in the array, right? Whatever level of access you want to give somebody to individual storage groups or to the entire frame. But the ability to do this kind of thing helps us with multi-tenant systems, but also in large enterprises. Because again, if I want to pass the ability to do snaps to an end user, the last thing I want is an end user who makes a mistake and restores on top of somebody else's data. right? So I want to be able to control those kinds of things. They also shouldn't be able to make a read copy of somebody else's data and go put that somewhere else, right? Or make it accessible to them. And I've seen a lot of paranoid people with different things on the arrays, but the most paranoid I've ever seen is when somebody had juvenile court records on a system. Because evidently the laws around that make the things at the NSA look pretty nice. Because nobody wants juvenile records leaked ever, and wow, they're paranoid. But again, we can do the access controls and make sure that nobody other than the people authorized to use that system can make any copies or do anything with that data.
Do you still use gatekeeper devices?
You're welcome to have gatekeepers if you need them for anything, but they're no longer necessary.
Okay.